Hello everybody, this is Tommy and welcome back to my weekly physics explainer videos, and today we're going to be going over problem number 15.75, and it asks a block on a frictionless table is connected as shown in the figure below to two springs having spring constants K1 and K2. We want to find an expression for the block's oscillation frequency f in terms of the frequencies f1 and f2, which it would oscillate if attached to spring 1 or spring 2 alone. So one of the most important things to know for this problem is that when a force is exerted on this system, the force of the first spring and the force of the second spring will be equal to the force that was exerted on it. So for example, if a force were to move the block over and both of these strings were to be stretched, then the force that moved the block in that direction will be equal to the force of the first spring and the force of the second spring. And yeah, that's one of the most important things to know for this problem. Some of the equations that we have here are the frequency is equal to the square root of the spring constant over the mass, and we can arrange that to get the spring constant on the other side. And another important equation that we need to know is the force equation, of course. F equals negative k multiplied by the displacement, and I'll just get the force of the springs if a force were exerted on the system. So the professor gave us a hint that told us that the displacement of the first spring plus the displacement of the second spring will be equal to the overall displacement. So using this equation and the force equation, we can substitute the displacements so that we can get it in terms of the force and the spring constant. So if we were to substitute both of these, we would get force 1 over spring constant 1 plus force 2 over spring constant 2 is equal to the total force over the total spring constant. The total spring constant being just the spring constant of this entire thing with both springs combined. And we also know from the beginning that the force of the first spring and the force of the second spring is equal to the force that was put on the system. So we can just rewrite it as 1 over the spring constant 1 plus 1 over spring constant 2 is equal to 1 over the total spring constant. And if we were to rearrange this a little bit, to make it so that the spring constant is in a fraction, and we want to isolate it, we will get this equation right here. So after getting this equation, we want to substitute the spring constants using this equation right here, since we know that the spring constant is equal to the frequency squared times the mass. So when we do that, we can get this equation. And if we simplify it a little bit, we can get this equation right here. And we know that the frequency, we know that from our original equation up here, that frequency is equal to the spring constant over the square root of the spring constant over mass. So if we take that for our block, the frequency of our block will be equal to the total spring constant, which is the spring constant of both of these springs. Then if we do that, the mass will cancel out because it's m over m, so we don't have to worry about the mass, and we can substitute k, and we can substitute the spring constant, the total spring constant for this term right here, and we will end up getting this solution, which is the frequency of the block completely in terms of the frequency of the first spring and the second spring, and that will be our solution. Thank you.